Fourier space filtering. I have a real vector times series x of length t and a filter h of length t. H is a filter in Fourier space, real and symmetric. It is approximately 1/f. I would like to filter x with h to get y. Suppose t equals t and ffts of length t could fit into memory, neither of which are true. To get my filtered x in Python, I would do. Since the conditions don't hold, I tried the following hack. Select a padding size p less than t/2, select a block size b such that b plus 2p is a good FFT size. Scale h via spline interpolation to be of size b plus 2p greater than t, h underscore scaled. Y equals, loop. Take block of length b plus 2p from x, called x underscore b. Perform y underscore b equals if, FFT, x underscore b, asterisk h underscore scaled. Drop padding p from either side of y underscore b and concatenate with y. Select next x underscore b overlapping with last by p. Is this a good strategy? How do I select the padding p in a good way? What is the proper way to do this? I don't know much signal processing. This is a good chance to learn. I am using cuff to speed things up, so it would be great if the bulk of the operations are FFTs. The actual problem is 3D. Also, I am not concerned about artifacts from an acausal filter. Thanks. Paul.
You're on the right track. The technique is called overlap-safe processing. Is t short enough that FFTs of that length fit in memory? If so, you can pick your block size b such that b is greater than 2 * min, length x, length h, and makes for a fast transform. Then when you process, you drop the first half of y underscore b rather than dropping from both ends. To see why you drop the first half, remember that the spectral multiplication is the same as circular convolution in the time domain. Convolving with the zero padded h creates weird glitchy transients in the first half of the result, but by the second half all the transients are gone because the circular wrap point in x is aligned with the zero part of h. There's a good explanation of this, with pictures, in Theory and Application of Digital Signal Processing, by Lawrence Rabiner and Bernard Gold. It's important that your time domain filter taper to zero at least on one end so that you don't get ringing artifacts. You mentioned that h is real in the frequency domain, which implies that it has all zero phase. Usually, such a signal will be continuous only in a circular fashion, and when used as a filter will create distortion all through the frequency band. One easy way to create a reasonable filter is to design it in the frequency domain with zero phase, inverse transform, and rotate. For instance, I'm pretty new to Python, please let me know if there's a better way to code this. HT at the top has lots of ripple. This is due to the discontinuity at the edge. Trot in the middle is better, but still has ripple. Twin is nice and smooth, at the expense of flattening out at a slightly higher frequency. Note that you can extend the length of the straight line section by using a bigger value for n. I wrote about the discontinuity issue, and also wrote a MATLAB/Octave example in another so question if you want to see more detail.
If you want to support the channel, please consider liking and subscribing.